Okay, hi guys. So we'll be continuing from the previous lecture wherein we left in between uh, after seeing the spin multiplicity in case of chromium. Okay, so now from the previous lecture only I'm going to cover one more topic. So this is lanthanide with number 57 and actinide with number 89. Okay, so what would be the configuration for uh, lanthanide? So it would be from the starting. Let's start 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, then 4p6, 5s2, 4d10, then 5p6, 6s2, and finally 4f1. Okay, so you can calculate. This is 10, 12, 18, 20, 30, 36, 38, 48, 54, 56, and 57. Total number of electrons are 57, and in this case you can go for the initial one, and the final would be 6s2, 4f14, 5d10, 7s2, and rest it would be 5f. So I'll leave you for determining this number, but I can assure you that this is a F block element. So in both the cases, this is your homework. So in both the cases, lanthanide and actinide belong to the the last electron is entering the 4f orbital. Okay, hence they are F block elements. But there is a certain thing here that um, as far as the configuration of La is concerned, so with respect to configuration of lanthanide, it should be a F block element, but in periodic table it is placed in D block. Okay, so why is this the case? So this is due to avoid undue expansion of periodic table. We place it in the D group itself, but the actual positions belong to the third group and sixth period. So this is for the lanthanide, and this is for actinide. It belongs to again third group and seventh period. This is for lanthanide, this is for actinide. Okay, and the corresponding elements after the lanthanide and actinide would be called a part of lanthanide series here, and here they would be called a part of actinide series. So both of the series contains 14 elements. Okay, and a total of 28 elements would be there. So 28 F block elements consist of lanthanide and actinide series, both having 14 elements. Okay, so next concept is we'll be saying exception of Afbau principle. Okay, Okay, so in case of electronic configuration of lanthanide and actinide, last electron enters the 5d and 6d subshell respectively instead of entering 4f and 5f respectively. As we can see here that the configuration of La57 would be Xe54 and 4s2 and 5d1. So we actually saw different in the previous case, so why is that the case? And similarly for actinium or other actinide 89, it would be again radon 86 and 7s2 61. So why is this the case? We'll explain in short a while, and we'll also explain why the previous two electronic configurations. So we'll be seeing whether they were right or wrong. Okay, so this was 6s2 rather than 4s2. Yeah, so why is this the case? So exactly, so this is the exception to Afbau principle, and we'll be shortly seeing what we have already seen a few seconds back when we were talking about lactinide and actinide series, that why they were actually placed in D block elements, rather they should have been placed in placed as F block element. Okay, so that thing would be answered here, and why those two configurations which we have seen were wrong. Okay, so this is the correct configuration of lactinide, and we'll be seeing why. So just remember that for F block elements they have exception in electronic configuration, and that exception is that first, after let's say Xe54, first 6s2 is filled. Okay, then first 5d1 is filled, then 4f 1 to 14 is filled, then 5d 2 to 10 is filled, then obviously 6p6 is filled, then 7s2, then again 6d1 is filled first, then 5f1 to 14 is filled, then 6d 2 to 10 is filled, then 7p6 is filled, then 8s2 is filled. Okay, so just remember that instead of directly electron going to 4f1 as we saw in the previous configuration, here in between the first electron here would be going to 5d1, then it would be going to 4f. Okay, but in this case already with the filling of 5d1, it is the number of electrons are already filled up, hence we don't need any electron is for in 4f, hence lactinide was placed here as a D block element, but it was actually of 4f, rather F block element. Okay, due to the exception of Afbau's principle. Similarly for actinide, we would be seeing that after 7s2, 6d1 would be filling instead of 4f 5f1, hence this would be the configuration. This is the correct one. Okay, and both the above two configurations are wrong one. This and this are wrong configurations. So C, exception for correct configuration. Okay, due to the exception that after 6s filling, 5d1 would be filling ahead of 4f. Okay, So just keep this in mind. This is an important exception. Okay. So now let's see some example. So suppose you have to fill in x62. X is any element with atomic mass of 62. Then the configuration would look like xenon 54, then 6s2. Then first, according to the rule, 5d1 would be filling, then rest of the electrons will go to 4f. So 4f5 would be the configuration here. Okay. In the next case, when we have x63, then it would be nothing but xe54, 6s2, 5d1 and 4f6. Just observe the two things wherein exception is coming to the picture. Okay, but as you can see that if by putting one of the electrons here to the 6 filled electrons in f orbitals, it can get to half filled state or configuration. Okay, hence it is more advisable, and rather it will take place in which one of the electrons here would be coming from 5d. Okay, so as a result we'll be getting, this is the configuration: xenon 54, 6s2, 5d0 and 4f7. okay, 5d0 won't be there, so in this case directly we can write it as 4f7. So this would be the configuration of xenon 63 because of half filled rule, which is applicable here. Okay, next let's see the last example for this lecture. We'll have a compound Z with atomic number again 95. So the configuration would be radon 86, then we have 7s2, 6d1 and then 5f6. So again what will happen is, again this f orbital is just one electron away from getting half filled, so it would form like 5f7. This electron, d electron, will jump into the f subshell, f orbital or f subshell, whatever you may want to call. So this is radon number 86. Okay, so again here also half filled rule applicable. So I hope in the past two examples you are able to notice that first the exception to Afbau principle will take place, in which 5d1 and 4f6 should be the configuration ideally, and then half filled rule will be applicable, in which you transfer the 5d electron to, or rather d electron to f orbital. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing outer electronic configuration of elements, then some of the examples pertaining to that or relating to that. Okay, so till then, good luck and goodbye.